So let's talk about configuration of feedback loops within the endocrine system. So what this means is hormones are typically secreted and regulated in what we know as feedback loops. So a hormone's production is not an endless thing. In fact, it is a very, very tightly controlled process. So the production of a hormone and the regulation of hormone happens in a few different ways. And the first way we regulate a hormone is what we call a negative feedback loop. The function of a negative feedback loop: in a negative feedback loop, a hormone acts on one or more target organs to induce a change. Remember that, a change, either a decrease or an increase in circulating levels of a specific component. And the change in this component then inhibits the secretion of the hormone. So basically, the hormone leads to an activity, and that activity thereby decreases the production of the hormone. Great example is when you eat a burger. When you eat a burger, the burger is broken down into glucose. The glucose levels in your blood will increase. Immediately that happens, that glucose signals the pancreas to produce insulin. The function of insulin is to reduce blood glucose back to its normal range. There is a normal range in which blood glucose must exist for you to be healthy. So the function of insulin is to reduce the blood glucose levels. So blood glucose levels, increase in blood glucose causes increase in insulin, which then causes a decrease in blood glucose. So that's a negative feedback loop, okay? There's also what we call a positive feedback loop. In a positive feedback loop, a hormone increases levels of a specific component, and this component stimulates secretion of the hormone even more. This often offers instability. So a great example of positive feedback loop is when a woman is in labor. When a woman is in labor, the baby's head hits the cervix, begging to come out, right? That heating of the cervix sends information to the brain to produce more oxytocin. The production of oxytocin actually stimulates contraction and pushes the baby to further move out through the cervix. And so, increase in the hormone production further increases the stimulus. So, that is a positive feedback loop. And we have one that's not in your textbook and sometimes is not typically put in this category, but we have a feed forward system. And we're going to talk about that later. Because it's not in your textbook, I'm going to skip it for now. But this system would be what is in control of a classical conditioning, or when you eat, for instance. A great example that we're going to talk about is when you eat and food gets into your guts. We have chemicals called incretins. And the function of these chemicals called incretins is to go ahead and stimulate the production of insulin. Now, insulin is typically stimulated by blood glucose, but even before the glucose levels in the blood get high, incretins increase the levels of insulin secretion even before blood levels of glucose increase. Okay, so this is called a feed forward system.